So our new question, we've got a guy that swims in that direction at 3 kilometres per hour. And I'm going to say he swims at north 40 degrees east. He's always swimming in that direction. He's got a special compass in his mind and he just always swims off in that direction. He's out in open water. And out in the open water, he's going to encounter a bit of an issue. There's a tide running in that direction, but fortunately, it's only running at 2 kilometres per hour in a south 10 degrees west. I want to know how long it's going to take for him to swim from his starting point to a point that's in line due north 300 metres away. So I don't mind if he swims out in that direction to get there, or that direction, or that direction, but how long is it going to take him to actually go from the beginning and end up 300 metres later due north of where he started? He might be some distance west, he might be some distance east, but how long is it going to take him to cover 300 metres in a northerly direction? You can swim east and west as far as you like, but how long till, if there's someone looking at him from this direction here and someone else looking straight in a line from that direction, they wait until he's hit that line. How long does that take until he hits that line? So we need to work out the two vectors that we've got, and we need to add them together and get a resultant vector. So first of all, I'm going to write them in component form. So his swimming vector in component form would be 3 cos 40i, or 3 cos 50i plus 3 sine 50j. The reason I do it that way is I'm used to working with this angle in here with respect to the x-axis. But if you wrote 3 sine 40 and cos 40, because it's 40 degrees, you'd still get the same answer there. So that's what his swimming vector is. Now, what about the current? What's its vector? Now, with respect to I, which I is out that way, this vector has got a negative amount of I, doesn't it? So it's going to be negative 2 cos 80i. And the reason I chose 80 again is I've got that angle in there, which is 80. So it's negative 2 cos 80i. And it's also down, so it's negative 2 sine 80j. But if you used the angle of 10, well then this would be sine of 10 and this would be cos of 10. You'd still get the same thing because we know that cos 10 and sine 80 are the same and sine 10 and cos 80 are the same. I want to add up those two vectors to get a resultant vector. So it'll be 3 cos 50 minus 2 cos 80 I, and 3 sine 50 minus 2 sine 80 J. Now, one thing we learnt from the last question is the horizontal amount of movement is irrelevant to us. What we care about is how long is it going to take him to cross the river, which is vertical, which is the north-south direction. So we really only care about this component of his velocity, which we've already got worked out there. So we really only care about this 3 sine 50 minus 2 sine 80. 3 times sine 50 minus 2 times sine 80. So the bit that we care about is worth 0.3285 kilometres per hour. Now, it's positive, not negative. So what they're saying is that we've got a whole lot of horizontal movement. I don't care which way horizontally he ends up. But if you're looking at this river, which is 300 metres wide, his vertical movement, his speed going across there is 0.3285 kilometres per hour. So that's going to be straightforward now. Right? We want to find out the time it takes to cross. So time is distance on the speed. Let's do it all in kilometres. So it's 0.3 kilometres on 0.3285 kilometres per hour. The answer will come out in hours. 0.3 divided by 0.3285. It's 0.913 hours, which is 54 minutes and about 48 seconds. So when the water is not just flowing directly left or right, but there's a bit of vertical component in it, we need to find the resultant north-south or vertical component to work out what his overall time would be. It will change due to the water flowing.